Hey, what's up, Chem Peeps? We're going to take a look at a couple of very quick practice problems about polyprotic acids. This first question is asking us to determine which of the following choices best represents a solution of sulfuric acid. To successfully answer this question, we have to remember a couple of things about sulfuric acid. 1. Sulfuric acid is a strong acid. And 2. Sulfuric acid is a polyprotic acid. There are two ionizable hydrogens. The first ionization will look like this. Boom. But then recognize the HSO4- ion will also act as an acid, but this time as a weak acid. Boom. Second ionization of sulfuric acid. Again, it's important to recognize that H2SO4 is strong and HSO4- is weak. So what does that tell me? All of the H2SO4 is going to completely form HSO4- and hydronium ion. So I shouldn't see any H2SO4 in solution, because it's going to completely ionize into these things. But then HSO4 is only going to partially ionize into SO4- and additional hydronium ion because it's weak. So as I look at my answer choices and as I look at my key, I should have no H2SO4. I should definitely have some HSO4- and hydronium ion. And I should also have a little bit of sulfate ion, or SO4-. Not as much as the HSO4- because the HSO4 is a weak acid and will not completely ionize. The image that best represents that is option B. Notice that option A would represent H2SO4 if it were a super weak acid. Here it's showing absolutely no ionization whatsoever. Option C shows that not only is H2SO4 a strong acid, but the HSO4- is a strong acid as well, which is incorrect. Option C shows not only the complete ionization of H2SO4, but also the complete ionization of HSO4-, because in option C, all we see is sulfate ion, SO4-, and hydronium ion. All right, let's take a look at this second problem, which also asks us to think about some of our understanding of polyprotic acids. This time, we're given arsenic acid, H3ASO4. We're told it has Ka values in no particular order of 10 to the minus 7, 10 to the minus 2, and 10 to the minus 12 for the equilibria shown below. We're asked to assign the Ka values to the correct equilibrium expression. Well, as I take a look at this first equilibrium expression, this shows Ka1, or the first ionization. And even though it's a weak acid, it is going to represent the strongest of the three, which will indicate by a Ka value of 10 to the minus 2. Keep in mind then that the subsequent acids that are formed are progressively weaker and weaker. So H2ASO4- will be weaker than H3ASO4, but stronger than HASO4-2-. So we'll assign a Ka value for the second ionization of 10 to the minus 7, which leaves us with our weakest acid, HASO4-2-, which we'll assign 10 to the minus 12. Boom, done.